Okay, this question talks about an exact test. Well, we only know one exact hypothesis test. We've got a bank that is interested in this 15%. We are looking at whether there's a higher percentage of customers aged 25 compared with the original, and the original 15% of the savings account holders were 25 years or under. We want to see if that proportion of 15% has changed. So we can see it's an exact test. The only exact test you know is a binomial. Your hypotheses for a binomial test, we're always testing the value of p, so you've got a p-value to test here. Okay, we've got to decide whether it's a one or two-tailed test. Well, it's just testing whether it is a higher percentage, so it's going to be a one-tailed alternative. We're only interested in a higher value of p than the original one. You're going to be looking at the probability. Well, we've got a binomial model. Okay, we've got a probability here, so that's going to be your p-value, and your n-value, well, how many? We need a sample. We had 120 in our sample, so that's your n-value. And we want the probability of the tail we're in. So the observed value was 29. Okay, now if the tail probability for a one-tail test, we're only going to be impressed if that 29 is a big number. So we need the probability that 29 or higher has to be impressive. So we work out the probability of x being greater than or equal to 29. Now for that we need our outcomes diagram, 28, 29, 30, ... So we need to tick the ones we want. We need to do a subtraction from 1, in fact, to get the probability of being greater than or equal to 29. And that's what leads to our tail p. So we get our tail probability, we get our test p. Okay, now for a two-tail test you have to double the tail probability, but the test p is actually the same as the tail probability on a one-tail test. And then we have to compare that with a significance level of 0.05 and make a suitable conclusion. So I hope that helps. Try and put your solution together if that didn't go right for you first time before looking at the mark scheme. But the mark scheme is going to appear in a minute. So here is that mark scheme. They use this pi instead of p, but don't worry, I'm expecting to see a p there. Here's the binomial, here's the tail probability. They haven't clearly labelled both because it is the same probability as the test p. That's compared with your significance level, and because it's very low, they've rejected h0. And then look at the wording of the conclusion. There is evidence, and you do have to put it in context, so all those underlined words need to appear.